Last talk of the day, man. I hope you guys stay awake. I hope you've had plenty of coffee and you're not drunk already. Just think about the goal, man. We're going to talk about some cool stuff. Hopefully you'll find it interesting. But after this, plenty of drinks. You can get hungover, do all this good stuff. So stick in there with me, man. Stick in there. So my name's Brad Antoniewicz. I work for a company called Foundstone. We do all that strategic, tactical, security consulting, all that stuff from, embedded device control system penetration testing to maturity assessments, policy reviews, all that good stuff. And also incident response. We're part of a bigger cloud called McAfee, which is part of an even bigger cloud called Intel, and I do some research for the team there. So what I'm going to talk about is some of the research that I've been working on around 802.1x. I'd say the research is about, maybe 80% complete. It's almost there. It's pretty far along. I've done some good work, and so hopefully you guys will like it. I'm also an adjunct professor at NYU Poly. I teach vulnerability analysis and exploitation, and has authored some books and that kind of stuff. So I hope you'll like everything. So our agenda for today, what are we going to talk about? First of all, if you don't know anything about 802.1x, we're going to give you a little bit of a primer into it. We'll tell you how it works, what's going on with it, all that good stuff. And then from there, we'll talk about some of the attacks that are going on nowadays that a lot of people have been looking at, and sort of the established ones. We'll introduce some updated tools to help out with those attacks. And then really what I really care about the most and what I've been really working on is fuzzing all of this stuff. And so I'll give you some cool fuzzing tools and help you guys find some vulnerabilities. So hopefully everybody will love it. So by show of hands, how many of you guys actually know what 802.1x is? Yes! Awesome. I was hoping there wasn't going to be everybody who thought 802.11. Everybody always confuses that because there's a 1 in both of them, and I don't know. So good. So I'm glad most of you guys know what it is. If you don't know what it is, it's basically a standard that defines how computers do port-based access control, right? Or network access control. So essentially, the idea is, in most cases, not all cases, but in most cases, 802.1x defines how can a user join a network and be authorized to join that network before they get an IP address. So how can you sort of authenticate that user? And so that's what we're really talking about today. It's used in a couple of different areas. The standard defines 3 different roles. Starting from the right, there's the supplicant, right? And this is your client or whatever. There's an authenticator. The authenticator is what allows access onto the network but doesn't have the brains to say this user's actually authenticated. Who does have the brains is the authentication server all the way on the left. So this authentication server is the one that really can tell the authenticator whether or not to allow access onto the network. And this is usually a Radius server, something along those lines. Now, in 802.11, there's some sort of interesting things that can happen, right? So everything between the authenticator, in 802.11, the authenticator is really an access point, or Frankie Muniz here. And so the access point speaks wirelessly to the client, okay? And now there's a wireless communication that happens, and then on the back end between the access point and the Radius server, there's sort of this other communication on the wired side that facilitates that communication back and forth. Now with sort of standard Ethernet, the authenticator changes a little bit. So the authenticator is essentially your standard network switch. This has a wired connection to the supplicant. In this fact, it might be a laptop or anything plugged physically into the switch. And then there's still an 802.1x communication that happens between them, and then a same Radius sort of communication that happens between the authenticator and the Radius server. So sort of similar. The difference is one has wires, one doesn't. Now, what was also pretty interesting to me about all this is, so I've been doing wireless for a little bit now, and what was always interesting about it to me is there is this clear demarcation point between the sort of an untrusted environment, right, between the client and the access point, and then a totally trusted environment. And the way that .1x works is that data from the client is being sent all the way into the untrusted environment through the authenticator, through that middle piece, whether it be an AP or a switch. And that data is being sent back and forth, and there could be a lot of data that goes back and forth between that. And so that was always really interesting to me. You know, you have this completely untrusted source, and they can send all types of data to a really, really trusted source, right? Like your authentication server sometimes has Active Directory integration. It could be, you know, on the domain. It can have some pretty serious accounts on there. So it was sort of interesting to me. So what I started to do was, initially when I was sort of creating a lab to do some of this research, what I did was I had like a actual laptop with a wireless client, and then an actual AP, and then an actual server, and then they were all actually set up. It was a real situation. But I realized I didn't have to do any of that, because that was just a big waste of time. What I could do is simulate the entire environment within VMs, right? So it's pretty easy to do. So what I have is I'm targeting the Radius server on the back end, and so I have a Ubuntu VM that's pretending to send data to the Radius server as it would expect it from the authenticator, as it would expect from the AP or the switch. And so I started to play around with this. I'll kind of show you what I started to do. So here is an admittedly old version of Cisco ACS. It's 4.2. If you're familiar with it, it is actually on an end-of-life track. But it's what really got me interested. About 8 months ago, I started to play around with this. I had a copy of Cisco ACS 4.2, and so I started to play around with it. So if you notice here, I have this going. And if you look on the bottom, there's this csauth.exe, and that's running there, and that's just sort of running, hanging out. And I started to play around with this. Now, in the foreground here is my Ubuntu system. It's just in a different tab here in my VMware system. And if we look over here, let me just clear all this out. I have an SSH window in the foreground that's connected to my Ubuntu system. So I started to play around with this. Are you guys familiar with WPA supplicant? Yeah, so WPA supplicant, if you haven't played around with it at all, it's basically a Linux supplicant. It can be used for wired 802.1x authentication and wireless authentication. And the way that you configure it is through a configuration file, and it's just called, you can name it whatever you want. I have this one named eep.conf. And it's a pretty straightforward configuration file. You can sort of see everything that's in there. And so I was playing around with this, and I was like, all right, well, I want to try to hack stuff. I hear, you know, A's are good characters. Let's see what happens. So I put in a bunch of A's, and I'm like, all right, that's cool. I can do a bunch of these in there. But what happens if I don't know, man, maybe I'll just get a little weird with it, and I'll just paste these in here a whole bunch of times. So I just paste like a whole bunch of them in there, see what happens. And then what I did was I wrote this script that basically wraps around a tool called EPA Overland Test, and that really does it communicates via Radius to the authentication server. And so everything that I'm sending is going to be encapsulated within Radius going over. So it's sort of like it's coming right from the access point. So I have this script set up so I don't have to do all this crazy typing and stuff. It sucks to do. Just learning how to do that. And so I sent this, and if you look in the background, you might have missed it. That csauth.exe just sort of disappeared, right? And I was like, what? Man, where did it go, right? Like what? How did these processes just disappear like this? Sort of weird. So what I did was I started to look at it, and I was like, all right, man, you know what I need to do? I got to figure out what's going on. I got to use this debugger here. Let me jump on that. I'll attach my debugger, tell it to go. We'll jump back over, and we'll send the same thing. See maybe if we could figure out why this process keeps crashing. And so I looked, and very early on, I noticed that. And I was like, oh, crap, man. I need to start researching this whole area. Because that's, it's interesting. I don't know how those A's somehow got somewhere. So I was sort of interested in that. So that's really what spawned about 8 months ago. That really is something that got me interested in this whole topic. I was like, oh, man, I need to start, see if I could fuzz it. Let's try to find some more vulnerabilities that are, like, amazing like that, right? Like, since it's 1999 type stuff. It's amazing. So I started to look into it. So I was like, all right, let's start diving into this. And so if you know anything about 802.1x, what really at the core of 802.1x is something called EAP. EAP is Extensible Authentication Protocol. And what this protocol does is it's a really basic, very simple protocol. It has a request, a response, a success, and a failure. right? Really simple messages. And on top of those requests and response successes and failures, you can have other EAP types. Things like PEEP or EAP TTLS, EAP MD5, there's just an absolute ton of those. And those messages get sent back and forth, and if the authentication server or if the authenticator ever gets an EAP success, then that's what actually tells the AP or the switch to sort of allow it to connect to the network. So EAP is a pretty fine and grained. What happens between the client and, say, the access point or the switch is this EAP data gets sent by the client. It gets created and then gets encapsulated within 802.1x and sent over to the authentication server. Now, further within that EAP packet is, again, that's where you see all of those EAP type data. So there's a couple of layers of encapsulation that goes on. Now, once that EAP packet comes from the client to the authentication server, then something sort of interesting happens. The access point or the authentication, there's the Dalai Lama, I don't know. Anyway, so within that, there's sort of this decapsulation that happens between the access point. So the access point decapsulates its data from .1x, re-encapsulate it within Radius, and then passes it over for the Radius server to sort of process and understand. So Radius, let's talk a little bit about that. If you're not familiar with Radius, Radius is a pretty established protocol. It's been used in a lot of things. It's used in 802.1x networks for sort of that back-end communication, but it's also used in like DSL and dial-up setups to help your, I don't know, grandparents get on the internet, whatever, I don't know, whatever they use. And then it also helps, like, you know, high school kids use torrents and download those anonymously through VPN. So Radius is pretty established and is used on the back end for a lot of authentication mechanisms and protocols. So it's been around for a while. And so that was sort of interesting to me too, because it was sort of this extra layer of encapsulation and complexity that could be sort of interesting. Now, I mentioned this a little bit, but I want to underscore it a little bit, that the Radius server, although it can be self-contained, it can also relate back to a database of some sort. So again, this could be Active Directory, it could be, you know, if you have secure ID, any of that kind of stuff. There could be an active connection there. So if we start to sort of put all this together and think about, all right, if I want to hack this stuff, right, I need to understand its attack surface. So let's look at the overall attack surface that's involved. So first and foremost, I like to think about attack surfaces in three different ways, especially in this area, right? We have kind of the protocol level vulnerabilities in the protocols that, you know, the guys designing it didn't think about something, right? And they designed it, everybody implemented it, and they messed it up, right? So there's those protocol level vulnerabilities. And then there's also kind of configuration related vulnerabilities where, I don't know, the sysadmin screwed up, they've checked the wrong box, they clicked the wrong button, typed the wrong command, and they screwed something up, and that can make, you know, this whole thing vulnerable to attack somehow. And then there's, to me, the more interesting things, and those are sort of the handling issues. These are sort of software implementation flaws in which the developer who's handling the data coming from whomever wrote it wrong. And it could lead to memory corruption and all that kind of stuff. So if you think about the layers of encapsulation and sort of the complexity that happens, you have EAP, 802.1x, Radius, and then on the top end you have some external authentication handlers. So there's a lot of stuff that could go wrong here. There's a lot of layers of complexity that you could play around with. And then on top of it, to add even more complexity to it, there's all of these web UIs everywhere, right? So you have to think about, okay, well, some of my data that I send from a completely unauthenticated wireless client may end up in a web UI somewhere. And so one of the vulnerabilities we found was a SQL injection vulnerability that if you send a packet as an unauthenticated wireless client, it will land up in a log, and it's a little convoluted, but an admin would have to click that log entry, and by that admin clicking that log entry, they would initiate a SQL injection sort of attack. And that could do a couple of different things there. So there are a lot of cool things that you can do, but you have to sort of take those into consideration when you're dealing with the attack surface. All right, let's talk about some of the known attacks that are out there. And some of the things that we've sort of looked at. So generally, the attacks that are established now, they focus a little bit on the data between the Radius server and the authenticator. But most of them focus on the data between sort of the authenticator and the client. A lot of them focus specifically on that. So the first one that we'll look at, these are sort of protocol level vulnerabilities. It's all around sniffing, right? I mean, all this stuff is around sniffing. There's just data that's being sent back and forth between the Radius server. It's sent in the clear, and people can capture that and maybe take it offline to start brute forcing it, whatever they want to do. And then there's just data like, for instance, the EAP response identities is pretty well known. That one, you send the username in the clear, and that could happen over the wireless network, so anybody sniffing that can get it. Sometimes also the domain name's there, so you can get a little bit more information that might help you further attack, if you will, right? So there's some established ones, but these are all, again, protocol type of issues. The other type of issue that's really popular, that's been covered a lot, is the impersonation attack. So this is more of a configuration-related issue, and the idea here is that the attacker has control over the authenticator, and can basically convince the client to connect to them in some way. Now, if they do that, and there's something like TLS enabled, so with PEEP and EAP TLS, you can basically disable the client from validating who they're connecting to. You could essentially provide a false environment for the client to connect to and get maybe the credentials that they send through EAP TLS or PEEP. And so that was really easily exploitable via 802.11, because if you just send out a stronger signal to any of the access points that are around than the access point that they're used to connecting, well, they'll connect to you. And this was, there's a tool that myself and Josh Wright wrote called Free Radius WPE. So this is a cool tool. It has some downsides to it, though. One of the things is that you have to also have your own access point. So you need to set up an access point that feeds into Free Radius WPE. So just as part of this conference, I updated this other tool I wrote called Hostapd WPE. It's the same premise. It's just a patch for an existing Hostapd, but this does a lot more stuff. So one, you can do the same stuff you can do with Free Radius, because Hostapd can act as a standalone Radius server. So you can do all the standard stuff. This supports more EAP types, so you can start to attack EAP fast phase 0 if you wanted to. You just basically set this up and have clients connect onto it at the time that phase 0 happens. And then we also configured it so it'll always return success. So if you're trying to have a client connect to you, and you want to establish a connection to a client and maybe do man in the middle or start to attack the client's session in any way, this will, no matter what password the client gives you, it will just allow it to connect as it dumps the password so that you can connect to the real wireless. So it does a couple of cool things like that. It'll also request really weak methods first. So it'll request PAP for it first, which makes it a little bit easier if they're configured for multiple EAP types. And then I started to add some other patches I saw from the community. So one of the things I sort of hacked around with is I added in sort of Karma-style broadcast probe responses. So if a client is probing for any type of access point, this will respond back, so it will automatically connect to them and try to get as much data as they can. And then the last thing I added to it was the Cupid attack, or the heartbleed attack. So if the client is vulnerable to heartbleed as they connect in, this tries to get, grab some of its memory using the heartbleed vulnerability. So there's a couple of things I added to that. Hopefully you guys will find that useful. But really, at the end of the day, all this stuff is fine and great, but where the hell are all the handler bugs, right? There's tons of protocol vulnerabilities, there's tons of configuration-related vulnerabilities, but nobody has exploited anything in this area. I just don't understand it. And so there's been like a handful of exploits out there, or vulnerabilities out there, but no exploits. And so I was sort of pissed off about this. And so I started to say, all right, well, why? And to me, the reason why is because there was no tools that allowed people to start to look for vulnerabilities in this area. And so what I decided, I was like, all right, man, I'm going to start trying to fuzz the hell out of everything I can. I'm just going to get silly with it. So what I did was I used Peach Fuzzer. So is everybody familiar with Peach Fuzzer? Yes? No? Who is not? All right, I see a couple of no's. All right. So Peach Fuzzer is a pretty decent fuzzer. They have a paid-for version. I'm not endorsed by them in any way, shape, or form. But they have a paid-for version, and they have a community version. The community version's great, and also like the guy who made Peach, it's like a company now. The guy who made Peach responds to every forum question that you can have on their forums. So it's just like awesome, you know, like the guy's a really good guy. So I use Peach because I've used it on a number of different projects before. It's basically a fuzzer. If you haven't messed with it before, the way that it works is it takes everything and creates a data model out of it. So this is where you would structure what an EAP packet would look like. You would literally draw out what an EAP packet would look like in XML, and then you would feed that down to a publisher. The publisher takes it and formats it for network traffic. It'll format it, in this case it's the UDP publisher, so it'll format it, encapsulate it within UDP, and then you can send it out. So it's really nice and easy. We're going to be targeting two agents, the Radius server, and also we're going to go back and try to target the supplicant as well. And the reason we're not targeting the authenticator, so not the switch or the AP, is because you don't have a lot of control over that. Right? So the problem is that usually the switch is some embedded device or the AP is some embedded device, and they have all types of back-off algorithms so that if it sees you flooding it with data, it tries to regulate the speed at which you send it at, and then you can't really fuzz effectively, right? So I sort of ignored that for now, but that's sort of on the to-do list a little bit. All right, so what I did first and foremost was I just got silly with RFCs. All I kept doing, I just found as many different RFCs that I can find. I data modeled them all. So there's every EAP type, almost every EAP type that I could think of or I could find is data modeled out there for you. So all you have to do is just grab it. It's built in a very modular fashion. So if you have, say, MSChap v2, that feeds into another data model, that feeds into another data model, and then you can use it. So if you need MSChap v2 for another purpose, it's used in a lot of different areas, you can just pull that data model out and use it for your own purposes to fuzz some other stuff. So both of those feed up into a Radius or a 802.1x data model. And then from there, I started to discover that a lot of these Radius servers, they all act different. I don't know what the plan is with that, but they all just sort of respond differently to different requests. So I had to create different fuzzers for those different Radius servers that I came across. So I had to do all that. All of this feeds into Peach's default UDP publisher. So this is all focused on fuzzing kind of the Radius side of stuff. That's Michael Seratops. And then I also created a whole bunch of other publishers. So there's some interesting ones that I thought you would need. So a lot of times you don't want to write this huge, crazy, complex data model and then feed it into the UDP publisher. Sometimes you just want to fuzz EAP and not Radius. So I created a Radius publisher. So you just have the EAP data, you send it to the Radius publisher, it formats it appropriately and sends it out, and you can fuzz all of EAP. On the reverse side, if you wanted to fuzz, the supplicant, you can do that as well. Peach has sort of an Ethernet publisher or raw Ethernet publisher, but I was having some problems with it, so I rewrote it, and so you can do that. And then the biggest thing, the hardest part about all of this was those TLS sessions. So with PEEP and EAP, TTLS, and all that, those establish the tunnel, and you don't care about what happens outside the tunnel. You want to start to focus and fuzz everything inside of the tunnel. And so I had to write a bunch of publishers that actually do all of that. They establish those TLS tunnels and get everything ready to go, so you can just start, sending junk through that tunnel with the hope that something will crash. So we get pretty good coverage. The other thing that we do is to account for all those web UIs, I had to modify some of Peach's code so that it would include LDAP injection, command injection, cross-site scripting, SQL injection, all of that stuff. So I modified its string mutator to include all of it too. So did a crazy amount of work. We get some good coverage though on it. I'm going to be releasing it all free. Don't judge me on my code, man. It's free stuff. Don't hate me because of that. Just trying to be good to the community. And so you'll find some crashes with it, man. So I don't want to get too specific, but I do want to show you this one. So this is a newer version of Windows running a network policy server. And so I have another script. This is just a script to wrap around Peach. When you run Peach, you have to do a kind of complex command. So I'm just going to run this. It's asking for my password. I won't tell you what that is. And then it's going to initialize Peach and start to fuzz everything. And if you pay attention to the background window, you'll see that you can get some crashes out of this stuff pretty quick. So I encourage you guys to download the tools and see what you can find, because there's some stuff to be found, for sure. All right, so let's talk a little bit about how to enable all this. So I'll pull this up. All right, so some of the tools. There were some existing tools that were already out there, tools, libraries, all that kind of good stuff. There's libeep and PyRadius, and both of those are good if you need to craft EAP packets, but there wasn't anything. So part of the difficulty with Peach is that it's written all in C#. It has a lot of Python extensions that make life a little bit easier, but I really wanted to write everything in C# so that it will work with Peach as fast as it could be. So I ended up having to there's a free Radius.net project, so I took that, forked it, so you can do a lot more hackery type of stuff. They were trying to use Radius packets for like real Radius stuff. I don't know. So I changed that up, I fixed that problem, so now you can hack with it a lot easier. And then I also created a whole new library called eep.net, and so you can really create EAP packets really, really simple, and I modified OpenSSL.net so you can do that sort of asymmetric SSL tunnels really easily. So if you wanted to create a packet or create one of these tunneled TLS sessions really easily, you just, if you're targeting the Radius server, you just create a Radius EAP session instance, and you can do that super easy. If you want to target the client instead, you can do that really quickly with an Ethernet EAP session. And then if you want to create crazy SSL tunnels, you can pretty easily with the SSL UDP instance. So the other thing that I started to do was I was noticing, I was playing around with these different EAP types and servers a lot, you know? And I started to see that they were all kind of different, right? They were all responding different. And over time, I was like, well, wait a second, you know, I could probably profile which Radius server is which just by looking at the responses I got back from a lot of them. And so I started to say, all right, well, maybe I could do this. I started to find some things. There was some special types of messages and the ways that would respond in the middle of a connection. And so I proof of concept a lot of that in this Radius EAP profile.exe. It's using all those .NET extensions to figure out, you know, what server you're connecting to. And so I was able to do that, and then also there was sort of some opportunity for brute forcing and enumeration. So it's sort of slow to do over Wi-Fi, try to brute force the password. It's just really not going to be too good. But you can do other types of interesting things like enumerate all of the EAP types that are supported, and just to sort of build a better picture of the network and how it's configured. So I implemented that into EAP enum.exe. But really what I really want to do, and I didn't have time to do it for this conference, but is to write a tool called WPA supplicant WPE. And so what this tool would do is it would implement all of those other attacks, and it would allow you to do it using WPA supplicant, so you can do it over the wireless or over the wire, depending on what you want to do. So that's sort of on my to-do list, and I expect maybe next couple of months. So keep an eye out on the GitHub and all that good stuff. Just some notes for researchers I just wanted to add in real quick. You know, just basic stuff like don't try to fuzz all this over wireless. It's just going to take you the rest of your life. You know, there's a tool called EAP Overland Test. Always use that. It's really good. NetSH LAN Reconnect is an invaluable built-in command when you want to fuzz like Windows 7 or Windows 8 supplicants. It's going to be a really useful tool for you. It sort of reestablishes that session. And then if you want to find the really good stuff, take a look at sort of, you know, page heap and all that, and make sure that's enabled to find some good stuff. All right, so the last thing I wanted to do is just to sort of finish the thought with that first vulnerability. I just wanted to exploit it, but I also wanted to bring back an idea for you guys, and that's the idea that after you try to exploit one of these things, not only do you sort of get remote code execution, but you could also redirect program flow to just allow you access to the wireless network. And so that's a sort of interesting thing, like, you know, your shellcode not just does whatever you want it to do, but it can also allow you access to the network. So I just wanted to keep that in mind too. So I'll show it to you. I actually, it shows you what sort of blunder I am. I wrote this exploit like a long time ago and then lost it. So actually this morning, during the keynote, I had to rewrite it, but luckily it wasn't too difficult to do. So let's see if it works, you know, we'll see. All right, so the idea here is, again, here's CS auth up here, and we're just going to look for some sort of proof of concept code. And Cisco, by the way, man, let me just tell you, Cisco, awesome. Those guys were super awesome with me. They sent me the latest versions of ACS so I can play around with it. They constantly sent me all these upgraded versions and let me keep working with it. They fixed this bug really quick, and they've been really good along the whole vulnerability disclosure process. So kudos to them. They rock. All right, so let's do a quick exploit on this. All right, do that, and now your computer can do math, calculate stuff, all that good stuff. So, thanks guys. So I clearly drank way too much coffee before this because I am all out of everything. I went through my entire 1 hour long presentation already. But I would like to say a couple of things. One, if you are a student and want a Foundstone bag, we had some left over from our training. So come on up. I have 3 of them. I'll give them to first come, first serve. And if you guys have any questions, feel free to ask. Yeah, go ahead. With ICE? No, I have not. I haven't done anything with that. Any other questions?
Does that exploit work with only the Windows version of Radius or free Radius too, or other?
This exploit, so this is specific to ACS, but there are other vulnerabilities out there for free Radius, for tech Radius, for SBR, Hostapd's Radius server. So there's a lot of different vulnerabilities. This one is specific for ACS. You know what, man? It was a lot of development. I don't know if I could put an hour count on it. It was just like a lot of writing everything so that I can create and forge packets. And then the worst part about it was that stupid, like, not to rant too much, but .NET and SSL streams are just sort of annoying. And if you want to do them in fancy ways, it's annoying. So yeah, I don't know about as much time, but there's definitely a lot of libraries that I wrote. But hopefully everyone will find new bugs in ICE and everything else new, Make the world a more secure place. Any other questions? All right, thanks so much, guys. I really appreciate it.